Have you ever pondered about what makes up most of the universe? It's not the stars, galaxies, or nebulae that we can see. In fact, the vast majority of the universe is made up of something far more mysterious: dark matter and dark energy. These elusive components make up a staggering 95% of the universe, yet they are largely invisible and undetectable. Dark matter is an enigma, an unseen substance that interacts only through gravity. Dark energy, even more baffling, works against gravity, and is causing the universe to expand at an accelerating rate. Despite decades of study, these elements remain largely mysterious. Scientists are still grappling to understand their nature, origins, and implications. It's a humbling thought, isn't it? We live in a universe where the majority of what exists is beyond our current comprehension. Yes, the universe is mostly made of elements we barely understand. Imagine a place in space where nothing, not even light, can escape. Welcome to the world of black holes, cosmic phenomena that have intrigued and baffled scientists for decades. Black holes are born from the remains of massive stars. When such a star has burnt out its nuclear fuel, it collapses under its own gravitational force, eventually crushing itself into an infinitely dense point known as a singularity. It's at this singularity where the laws of physics as we know them cease to operate. Now, let's talk about gravity. We're all familiar with it, right? It's the force that keeps our feet firmly planted on the ground. But in a black hole, gravity is in a league of its own. It's so intensely powerful that nothing, absolutely nothing, can escape it. Light, the fastest thing in the universe, traveling at about 186,000 miles per second, doesn't stand a chance. It's sucked right in. This is why black holes are black. They don't reflect or emit light. They're like the universe's invisible vacuum cleaners, sucking up everything in their path. But don't worry, black holes don't wander around the universe gobbling up planets and stars. They stay put, and anything that comes too close gets pulled in. So there you have it, the mighty black holes. They're the ultimate space oddities, the extreme end result of gravity's power. Black holes, the ultimate prisons of the cosmos. What if I told you that the universe is not static but constantly expanding? Yes, you heard that right. The universe we inhabit is in a perpetual state of growth, and this growth is far from leisurely. It's accelerating. Imagine a loaf of raisin bread baking in the oven. As the bread expands, the raisins move farther apart from each other. This is precisely what's happening with our universe. The galaxies are like the raisins, drifting apart as the space between them expands. This expansion began roughly 14 billion years ago with a colossal explosion known as the Big Bang. Since then, the universe has been spreading out, and recent observations suggest that this expansion is speeding up, not slowing down. Now, what does this mean for us and the universe? Well, in the distant future, this could lead to galaxies moving away from each other at such high speeds that they become completely isolated. The night sky, filled with distant galaxies and nebulae that we see today, will become much darker and lonelier. But don't let this get you down. This process is happening over such a colossal timescale that it won't affect us, or even 1,000 generations after us. Yet it's a humbling reminder of the dynamic nature of the cosmos. The universe is not just vast, but it's getting vaster every second. Ever heard of the most energetic events in the universe? Let's talk about gamma-ray bursts. These are not your average celestial fireworks, rather they are cosmic blasts that dwarf everything else in the universe in terms of pure energy. What exactly are gamma-ray bursts, you ask? Well, they are extremely intense explosions that have been observed in distant galaxies. They are the brightest and most energetic events known to occur in the universe. In a matter of seconds, a gamma-ray burst can release more energy than the sun will in its entire 10 billion-year lifespan. Imagine that, the entire life's work of our sun, outshone in mere seconds. These bursts are believed to occur when a massive star collapses on itself at the end of its life cycle, creating a black hole or a neutron star. The resulting explosion is so powerful that it shoots out jets of gamma rays, the highest energy form of light, moving at the speed of light. But don't worry, these bursts are incredibly distant, happening in galaxies billions of light years away. Still, their energy is so immense that we can detect them here on Earth with our telescopes. They serve as a stark reminder of the incredible forces at work in the universe. Forces that are capable of producing phenomenon of unimaginable scale and power. Gamma-ray bursts, the universe's most spectacular fireworks. What if our universe is just one among many? This mind-bending question paves the way for our exploration of the multiverse concept. Imagine a reality where there's not just one universe but a multitude of them, each playing by its own set of physical laws. This isn't the stuff of science fiction, but a theoretical possibility considered by cosmologists and physicists. The multiverse concept proposes that our universe is just one bubble in an infinite cosmic foam. Each bubble or universe could have its own unique laws of physics, leading to a staggering variety of realities. Some universes might be similar to ours, with galaxies, stars, and planets. Others could be entirely different, with unfamiliar forms of matter and energy, or even different dimensions of space and time. The idea of a multiverse also adds an intriguing twist to the notion of existence. If there are infinite universes, then it's plausible that there are versions of you leading different lives in other universes. In one, you might be a renowned scientist. In another, a famous musician. The possibilities are endless and mind-boggling. While the multiverse concept is still theoretical and lacks empirical evidence, it's a fascinating idea that challenges our understanding of reality and existence. It forces us to ponder our place in the grand scheme of things, reminding us that the universe, or should we say multiverse, is far more complex and intriguing than we can possibly imagine. Our universe might just be a tiny bubble in an infinite cosmic foam,